afternoon. Today, standing before you are the early childhood teacher from Annai Center. My name is Shoshana Jarrett. Here we have my colleague, Sally Daniels, Miss Renica Alfred, Luca Jarvis, Velda Merriman, Ezelia Augustine, Betsy Alvin. Today, we're tasked with the presentation of our early childhood science skit based on improvisation. We represent the Annai Center. I'll now hand you over to my colleague, Luca Jarvis.
Here we have a diagram of an external part of the human body done by Miss Shoshana Jurek. Here we have a model of the pulley done by Miss Keisha Smith. Also, we have over here a model of the water cycle done by Miss Keisha Smith. Now I hand you over to my colleague.
This is the model of a color wheel done by Betsy Alvin. Model of a flower done by Velda Merriman. Model of a wind bin done by Sultan Thomas. I will now hand you over to my colleague Betsy.
This is a model of a digestive system done by Mr. Shamcher. A model of the food pyramid done by Ms. Iselia Agustin. And the model of a food chain done by Ms. Renica Alfred. I will now hand over to Ms. Sally Daniels.
Here we have a model of the seed to show seed germination done by Miss Shania Lau. Here we have the model of the solar system done by Miss Luca Jarvis. Here we have the model of the beam balance done by Miss Sally Daniels.
So today we represent our colleagues that are far away and are not here today to present their model. That is Miss Keisha Smith, Miss Shania Lau. Yes. Thank you. We have the person behind the camera, Sir Can Thomas.
Hi, my name is Keisha Smith and I will be presenting my model of a pulley, how I created it and how a pulley works. To build my pulley model, I use the following materials: glue gun, egg trays, water paint, cardboards, cartoon box, paper glue, scotch tape, box cutter, flowers, grass, rocks, sticks, rope, scissors, and a sanitary cup. These materials help me create both the pulley system and a decorative environment to make the model realistic and attractive. How I made the model. I used a cartoon box and a cardboard to form a base and structure. The stick acts as the axle for my pulley wheel. I shape a cartoon box to form the wheel and painted it with water paint. I attached the rope around the wheel and the cup served as the load container. The rocks, flowers, and grass were added for decoration to complete the scene. A pulley is a simple machine made of a wheel and a rope that helps lift or move a load by changing the direction of the force applied. My model shows how a pulley helps work easier by allowing us to pull down on one end of the rope to lift a load upwards. Components of my pulley model and their functions. Pulley wheel made from the cartoon box. It spins when the rope moves. The groove is the wheel, keeps the rope from slipping. Axle, which is the stick, holds the wheel in place. It allows the wheel to rotate smoothly. Rope, the rope goes around the wheel. When I pull the rope, the wheel turns and the load moves. Support structure, which is the cardboard and the cartoon box, holds the pulley in a fixed position, helps the axle steady so the wheel can rotate freely. The cup is attached to the rope. It represents the object being lifted by the pulley. Decorative elements which I used: rocks, flowers, grass, and water paint. These make the model visually appealing. They help show the pulley in a natural or realistic setting. Together, these components demonstrate how a pulley makes lifting easier by changing the direction of the force, allowing us to lift a load by pulling down. In conclusion, my pulley model shows how a simple machine works and how everyday materials can be used to create a working lifting system. Thank you for listening. Hi, it's me again. I will be presenting my model of the water cycle. To create this model, I use the following items: rocks, glue gun, cotton, paper paste, printed trees, mountains, cardboards, cartoon box, water paint. These materials help me build the mountains, clouds, land surface, and overall layout of the water cycle. My model shows the 4 stages of the water cycle. Evaporation is when the sun heats the water in rivers, lakes, and oceans. In my model, this water area is shown using paper paste and cardboard. The heat causes water to turn into vapor and rise into the air. Condensation: higher in the sky, the water vapor cools and forms clouds. I use cotton to represent the clouds. Condensation turns vapor back into tiny water droplets. Precipitation: when the clouds get full, the water falls back to earth as rain. On my model, the cotton clouds are shown releasing raindrops. Collection: the water collects again in rivers, lakes, oceans, and even on land. I use rocks and printed trees to show landforms where water collects. From here, the cycle begins all over again. In conclusion, my water cycle model shows how water moves through nature using evaporation, condensation, precipitation, and collection.
Good afternoon. This afternoon I'll be presenting or explaining the model of a food chain where I made this model with the use of carton box, artificial grass, cotton, and toy animals. A food chain shows how living things get food. For example, the grass is the producer because it makes its own food. The cow eats the grass where the cow is the primary consumer. The jaguar eats the cow where the jaguar is the top predator. Now, when these animals die, decomposer like worm and fungi break them down and help them grow new plants. Thank you.
Hello everyone, my name is Khan Thomas. I'm here to present my model and which is Wen. So I have here the model for Wen has all the poles, North Pole, East, West, South. Good. Using this model, learners will be able to touch, feel, and see where the poles are. Good. As you can see here, good. Thanks for watching the video.
Good afternoon, everyone. My name is Rosalia Agustin. Today I am doing a presentation on food pyramid. My food pyramid consists of fats and oil, meat and fish, milk and cheese, fruits and vegetables, bread, cereals, and potatoes. I made my model out of cardboard, styrofoam. Thank you.
My name is Sally Daniels, an early childhood teacher, and this afternoon it is my task to present the model of a beam balance. The beam balance is used to teach math in the grade 1 classroom. It is used to weigh how heavy something is and how light something is. Thank you. Materials used to create this model of a beam balance. We use wood, bolt, screws, and strings.
My name is Shoshana Jarek. Today I will be presenting I'll be doing two presentations. One on the digestive system and second one on the external parts of the human body. I use mostly recycled materials for this model. I created a realistic, child-friendly teaching tool for early childhood learners. For this frame, I used a soft ply and I used some pieces of wood for support and a piece of plyboard at the bottom. For the mouth, this is a piece of foam. This is an artificial eye. Here I have a cup for the esophagus, and this is some wall plugs. For the liver, I use cardboard and a piece of cloth. For the stomach, I use plastic and cardboard. For the gallbladder, this is a balloon. For the pancreas, I use cotton. For the large intestine, I use a fat piece of rope. For the small intestine, I use a smaller rope. For the retina, it's the end of the rope, and the anus is at the bottom. Stop. All organs work together in sequence. Food enters the mouth, travel to the esophagus, in the stomach. Then nutrients are observed in the small intestine, then goes to the large intestine, and then it comes out through the anus as waste. So digestion begins in the mouth and it ends at the anus. So when you eat, your food is chewed and then it goes to the esophagus and it passes right down and go into the stomach. That's where it is chomped, and then it go right down to the small intestine here. That's where the nutrients is observed, and then the waste goes to the large intestine where it is passed out as stool or feces or poop. I created this model because young children learn best through hands-on concrete visual. This model helps them understand how their body processes food, which supports healthy eating habits and self-awareness. So this is my presentation on the digestive system. My second presentation here, I have the external parts of the human body. I did a front view and a back view. We have here the forehead, that's here, the eyebrow, here, the eyes, the ear, the nose, the cheek, the mouth, the chest, the arm, right here, the stomach, here, the hand, the finger, the leg, here, the knee, here, foot, right here, and the toes. Then for the back view, we have the hair, the head, the neck, the shoulder, the back, the elbow, the waist, the bottom, or you can say the buttocks or the butt, then the ankle, and the heel. So this is a presentation of the external parts of the human body. This is very, very attractive to early childhood learners because they can compare themselves with this and name the different parts of their body. Thank you. I used a blue kite paper and I strip it to form the borders. I also used black wool to form the lines for the label. I cut and paste the names. To make the picture large and visible, I cut and put together and paste pieces to fix the picture. I also use 4 cardboards and cut it to the size needed.
Hello everyone, my name is Luca Jarvis. I'm from Annai Center and today I will be giving you an overview of the solar system. So my model would have been made with foam wrapped in with insulation tape, also the use of cardboard and printed picture from the internet. I would have used straw to put my planets on and to bring out the planets. So I'll start with the sun. The sun is a giant ball of hot gas. It's make up 99% of all the mass in the solar system. It provides the light and heat that makes life on Earth possible. The inner planets, which are four: Mercury, Venus, Earth, and Mars. Mercury is smallest and closest to the Sun. Venus, hottest planet due to the thick clouds. Our home, our Earth, known to support life, and Mars, the red planet known for dust storms and volcanoes. Then we have the outer planets, which is Jupiter, Saturn, Uranus, and Neptune. Jupiter is the largest with a big storm called the Great Red Spot, and Saturn, famous for its beauty rings. Uranus is rotated on its side, has a pale blue color, and Neptune, strong winds farthest from planet Sun. There are other objects like the asteroids, where you can see here, and the comets. Asteroids are rocky objects, mostly in asteroids between the Mars and Jupiter here. Comets, icy bodies that from glowing tails when near the Sun. Then, in conclusion of my model, is that the solar system is a fascinating, complex place, from the hot inner planet to the icy world beyond. It shows diverse space can be. Thank you.
My name is Belda Merriman. This is my model of a flower and its spark. Here you can see the stigma, the anther, the style, filament, petal, the ovule, receptacle, pedicel, ovary, and the sepal. So I have created with empty carton box and binding wires.
Good afternoon, colleagues. My name is Betsy Alvin. Today I will be presenting a model of a color wheel, and this is the color wheel that I made. The materials that I use are a carton box, paint, bottle cards, a piece of arrow, and a cardboard. So how do I help my learners to know the primary and secondary colors? The primary colors are yellow, red, and blue. These are the primary colors. And in order to have the secondary colors, we have to mix the colors to get them. For example, the yellow and the blue, we have a green. The yellow and the red, we have an orange. The red and the blue, we have a purple or white. So the green, purple, and the orange are secondary colors, while the yellow, the blue, and the red are primary. And in order to have the tertiary colors, we have to mix them again so that we could have the tertiary colors. So the secondary colors are green, purple, and orange. So these are the colors that learners need to know in their everyday lives. Thank you.
Good afternoon, everyone. My name is Shania. Today I'll be presenting the model of seed germination. Materials that I use are cardboard box and foam. These are the life cycle of a plant. The first stage is seed, Second stage, radical. Third stage, sprout. Fourth stage, seedling. Fifth stage, young plant, and then adult plant. Condition needs for germination are sunlight, wind, and water. Thank you.
In completing this assignment, we were able to demonstrate how effective teaching and learning in early childhood settings can take place through improvisation and creative use of available materials. By using mostly recycled and unconventional items, we constructed models. Through improvisation, we discovered that meaningful learning tools do not require expensive materials or resources. Instead, they require thoughtful design, accuracy, and a clear understanding of the concept being represented. Overall, this assignment reinforced the importance of creativity, usefulness, and purposeful design in the early childhood science education. Improvisation not only enhances the learning experience but also models problem solving, sustainability, and reflectable skills that are essential for teachers and learners alike.